Hi everyone, today we'll talk about how the scientist simplifies a number. You may probably see something like this in your textbook, 10 to the power something, 10 to the power something. Why don't they simply write down the whole number, but have to use 10 to the power something? The only reason why is being smart. When the scientists want to express a very large or very small number, it is too time consuming to write down all the zeros. That's why we go for a shorter expression. It is called scientific notation. When you talk about the mass of the sun, it is 199,000,000,000,000,000,000,000,000,000,000,000,000 kilograms. It's 31 digits, very long, right? But use the scientific notation, you can divide it into two parts. The first part is 1.99 and the second part is times 1 followed by 30 kilograms. The first part is the digit term. It shows you what the exact number is. In most of the cases, just the first three significant figures are listed. In this example, it is 1.99. It must be a number between 1 and 9.99 so that you can't write 0.199 or 19.9. The second part shows how large your number is. You can see here 1 is followed by 30 zeros. That means the number has 30 plus 1, 31 digits. Now, this part can be simplified. 10 to the power 1 is 1 followed by 1 zero. 10 to the power 2 is 1 followed by 2 zeros. By this logic, how many power of 10 will make that many zeros following that one? Back to the example, 1 followed by 30 zeros can be written as 10 to the power of 30. So finally, the mass of the sun is 1.99 times 10 to the power 30 kilograms. When you deal with these numbers with 10 to the power 30, obviously 1.99 is not the real value of the number. To find out the real value, you have to move the decimal mark to the right for 30 digits so that the number is back to 199 and followed by 28 zeros. What happens if it is a very tiny number? Take the mass of the proton as an example. It is 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 because 10 to the power negative 1 has 1 zero. 10 to the power negative 2 has 2 zeros. So, how many negative powers of 10 will make that many zeros going before the 1? Therefore, in our examples, you can use 10 to the power negative 27 to represent those 27 zeros. And the mass of the proton is now 1.67 times 10 to the power negative 27. 10 to the power negative 27 means that you have to move the decimal mark to the left for 27 digits so that you can get the real value of the number. Using scientific notation can make the number simpler and shorter. It also shows us how large and how small the number is. If you see a number with 10 to the power 9, it is known as the order of magnitude of the number is 9. You will definitely know that we are talking about a billions or maybe a few billions, and you won't be struggling to count the number of zeros again. The order of magnitude also shows us the difference between two numbers. When you're comparing two numbers with order of magnitude negative 1 and negative 3, you will know that the difference in order of magnitude is 2. It means that this number with the order of magnitude negative 1 is about 100 times larger than another one. Or when you're calculating something, the actual answer doesn't bother you. The only thing you want to know is how large the number is. So when you do your calculation, you can simply ignore the digit term and use the order of magnitude only. Here is an example. 3.4 times 10 to the power 6 times 8 times 10 to the power 2 and divided by 5 times 10 to the power 3. You can give a good guess by just use 10 to the power 6 times 10 to the power 2 and over 10 to the power 3. So, roughly speaking, the order of magnitude of the answer should be 10 to the power 5. Is it smart enough? The scientists will say, no. You will still be annoyed when you keep writing 10 to the power something for every single number. So what we would do is using a symbol to replace the powers of 10. It is called unit prefix. In fact, you always use it in your daily life. How many meters is 1 kilometer? 1,000 meters. Pretty easy, right? So, What is the K for? 1 kilometers is 1,000 meters is 1 times 10 to the power 3 meters. So the actual meaning of the K is 10 to the power 3. Just like 1 kilograms equals to 1,000 grams and equals to 1 times 10 to the power 3 grams. How about the cm then? 1 centimeters equals to 0.01 meters and equals to 1 times 10 to the power negative 2 meters. It means that the centi, C, equals to 10 to the power negative 2. How about millimeters? 1 millimeter is 0.001 meter and equals to 1 times 10 to the power negative 3 meter. So now, the milli, the first m of mm means 10 to the power negative 3. You always hear nanometer, nm. The n, nano, represent 10 to the power negative 9. And the micro, mil of the micrometers, mu m, it is a little bit bigger and represent 10 to the power negative 6. When you mention how much data you have, you may say something like how many gigabytes he has. So the giga, g, of the gigabyte represent 10 to the power 9. And the mega, m, of the megabyte represents 10 to the power 6. That's why we say 1 gigabyte equals to 1,000 megabyte. It is because 1 times 10 to the power 9 byte equals to 1,000 times 1 times 10 to the power 6 byte. If you love to memorize all these unit prefix, here is a table you can check it on. But in DSE physics, only note those we mentioned is alright. In physics, we always use unit prefix and the scientific notation to simplify a very large or very tiny number. You should know what they are, and don't forget how they transform in the calculations.